Hello again. So I forgot actually. So this is about the week number 75, task number 1. I forgot to look at the solution of Shahed, Nooshmand, and actually it looks like it's an interesting solution, at least with some interesting things of the Raku language. So here's the solution. So this is about the collecting the change of the given coin types. So the coins are here, the amount is here, and we do it directly like that. Yeah, definitely it's not that simple because the function change is called here in this map, and the function is here. So this function receives the total and it receives the coins is copy. So we're going to modify the coins actually. So we take the first coin from there, and I don't know if it's important that this array is sorted or not. Then maximum count, yeah, see, so interesting thing. So you can use this division operator, and I wonder if it's the integer division or is it just a division. Let's just see. Where is it? Yeah, it's just the division, just the same as slash. Right, so that's the maximum number of coins. It's actually not an integer at the moment, but that's not important. So totals. If total is divided by this coin, so you can use this coin only to represent the whole amount, then you just return this max count, right? Otherwise, you return nothing if there are no coins anymore, right? But if there are some coins, then you start preparing the solution and you count from 0 to that max amount for the given coin, and so this is the number of coins, right, of this first type. You take the coin and and you also append the rest for the change, which is the remainder of the total minus the amount that you can represent with these coins using this number, and basically and the coins itself. But actually this is not the original coins, this is already the coins without the first type of the coin. And you see again, so that there's the Unicode character for multiplication. This time it's just again as the slash in division. It's just the same as the asterisks or the star if you want, and return the solution. Okay, so we go back to here, and so we see, so this function returns you the list of solutions, and what you do here. So yeah, it's not quite clear where you put parentheses. Basically, this is for this is a block of 4, right? And so you map. Basically, you take the result of this and you flatten that, and after that you apply this to you create array again. So I believe this and this are doing kind of opposite things. Probably it can be a bit simplified. I don't know how. Maybe you don't need actually any maps. Maybe you can just yeah, okay. So what this is doing, so this is the zip with XX. So basically you take the coins, you zip it with the what do we have here in solutions? Here in the solution we have the number of repetitions of each coin, right? And yeah, basically, wow, that's so. Yeah, so we take these coins, and here we have the number of repetitions, and basically we just print the result. And if like there are 6 options, 6 different variants for this for these input data, we probably should have 6 lines there. So Raku Shahed no Raku Che 1 the right. So this is what we have here after this operation. Yeah, so this is the correct result. Really interesting thing, and it uses, so first of all it uses a kind of couple of Unicode characters. Then, by the way, it's using this divisibility operator, which is a very useful thing. It's simple, but it's useful. And then it uses this. I still find like this and that together a bit strange, but nevertheless, like this one is really smart thing. So you apply the zip meta operator to the multiplication of, well, yeah, array duplication operator, and it's kind of so you create the table out of these, right? And you have the types and you have the number of each type here in the solution. solutions array. Okay, so yeah, that was a special edition, the addition to the first task of week 75 of the weekly challenge, and we were looking at the Raku solution submitted by Shahed Nooshmand. Okay, and this is the second part of this special edition. For some reason I also skipped the second solution of the Shahed Nooshmand, so let's look at this solution here. So this is about the histogram and finding the maximum rectangle, the rectangle of the biggest area. So okay, so here's the function, here's the program, and some data: max area, rectangle indices, rectangle height, and we stop this if we don't have any data. That's correct. Right, so then we scan all the data. So that's the length, basically the height, right, of the bin in the histogram. Then we have these indices, and the indices, I think we already saw something like that, but basically there's like from 0 to okay, so that's the zip operator, so that we so there's one range, there's another range, and we take those and we again apply this zip operator with the range creator operator. So that's wow. Right, but we saw this solution somewhere, so just look at the video of the main video for the second task of this week, and then we again make all those combinations, and then we select only the combinations that basically the min. What is min? So it's max of min. So basically, yeah, we're taking the maximum of the minimum. So basically, yeah, so we're first trying to find the maximum possible height by calling min of these. Basically, this is a range, right? So it's flattening. I believe this is just the range. Maybe we have to print this just to see the indices. Then we take the height. Actually, I think it's already there, right? Then you get this area again with the Unicode character, and then if it's bigger than the current maximum, we take these and we save additional things, and basically that's it. So that's the whole solution. Basically it's all the main solution is in these two lines, and I believe like this height is already calculated somewhere here. And we'll already take the maximum, but yeah, okay. And the bonus part of the task is to print the matrix. So we scan it from the maximum height of these cells to 1, down, counting down. So this is the height. So we print the height, and after that there's another loop from 0 till the end. So this is the index. And you see, so again, this Unicode character, basically we print either, yeah, so it's not printing as it is defined in the task definition, but nevertheless, so let's run this. Shahed Raku number 2, voila. So that's, yeah, so you see, so this is the rectangle, and where's the answer? The answer is here, so it's 12. That's a correct solution. So yeah, so maybe, but nevertheless, so maybe let's just look at the program and take this, and I want to print these indexes like dd, or maybe even say indices. Let's see what's there inside the Raku T. Right, so these are the indices, right? So it's like 5. Right, so these are already the indices after the filter. So that's like from, so these are the indices of in the original data, right? So it's like 2 and 3, 0, 1, 2 and 3, then 2, 3 and 4, then even 2, 3 and 4 and 5, and then the whole range, and like the range from 0 to 4. So yeah, basically this algorithm, maybe we can also try to print this one, say this one, if we can do that. Yeah, so this is what you get after this interesting construction. So first of all, so you have a range here, and you have a range here, and then you apply these zip operators, you create some ranges. So yeah, basically this is what you have here. They do not repeat, but they contain the part of each other. So yeah, that's the solution, and it gives the correct result. So yeah, I hope I will not forget it next time, but yeah, nevertheless, thanks a lot for this contribution.